I'm Shannon Lietz. I am the Red Team Leader at Intuit, and I've been doing development, security, and operations for quite some time. I'm one of the founders of DevSecOps, and have been working through a variety of different things. I've got personal interests and all kinds of cool stuff here, but primarily my two major passions right now are helping the DevSecOps community grow, bringing security to DevOps, and then also Hacker Girl, which is basically bringing more women to technology and helping diversity and inclusion.
Now, and you founded, or you started DevSecOps, like you coined the term, right?
Yes.
Yes. So we have the official DevSecOps here.
No tomatoes, please. I'm sorry. It still was needed.
It is still needed, and we can talk about that. We'll also be available at the speaker corner thing this afternoon if you want to talk about that or any other topics we bring up today. Hi, and I'm James Wickett. I work over at Signal Sciences. We actually have a booth here. So this is my first, so you're like, uh-oh, it's vendor talk, right? Well, this is like my first time to actually work at a vendor. I've worked at the large enterprise for many jobs before this, through like National Instruments, Mentor Graphics. But Signal Sciences, we are providing a product that's generally for large enterprise, and we're providing a next generation WAF and a RASP type option. I also have a couple courses on DevOps and DevSecOps over at LinkedIn Learning, or if you're familiar with lynda.com, and you can get to that. There's my short code there. And the thing that I really enjoy, I'm from Austin, and I have some good cohorts there down in Austin, Texas, and we help run the DevOps Days Austin, and we've been running that since 2012, so we've been really enjoying that. If you're ever in Austin and you want to come to a local meetup, or you come on to DevOps Days, hit me up. We'd love to show you a good time, have some barbecue, and get together. So, okay, so let's talk about the premise of our talk here. And we sort of came to this idea of the structure through this quote. And this quote is written by Stephen Beloven in his book called Thinking Security. He's the guy who wrote the book on firewalls in the late 90s, like the book, right? And this is a quote that is written by a security person to the security insiders. And he says this: companies are spending a great deal on security, but we read of massive computer-related attacks. He goes on to say, clearly something is wrong, and the root of the problem is twofold. We're protecting the wrong things, and we're hurting productivity in the process. And this is like I said, it's from security to security, and this is a pretty damning statement to security, right? It's like you're protecting the wrong stuff, and you're like slowing us down. So like that's worse than either option taken alone. In conjunction, it makes security in a tough spot. Would you say?
It does.
Yeah.
It makes it a really difficult profession.
Yeah, that's right. Well, let's talk about that. Like, what does that mean to be protecting the wrong things?
Yeah, what's interesting about protecting the wrong things is it's really about vantage point. One of the amazing things about doing security with a little bit more perspective on adversaries is that you get a vantage point perspective, and everything's about perception, right? So, when we talk about whether you're actually measuring the right things or the wrong things, if you're testing the right things or the wrong things, quite often that's really subjective. But what we wanted to do in our research here was actually figure out what the right things were through a little bit more empirical data. And so you're going to see today, like, the reason why we joined up was really to bring dev and sec together in a meaningful way and really kind of move and advance the capability forward.
Yeah, well, and so what have security told us before to protect, right? They give us these nice little building blocks, right? Some people might recognize these and be familiar with these controls and standards, and it's kind of like they've built a road with all these blocks, right?
Yes, I've heard all about the paved road to hell, according to most developers.
I like that. We were talking about this beforehand, but it's like, yeah, it feels like that, right? Because to a developer, I feel like I'm looking at this and I'm like, what am I supposed to do? Like, this is ridiculous, and it does feel like a paved road to hell. And like that is a fair thing to say. Yeah.
Hundreds of pages here, and really, we know that there's many breaches that have happened where there have been PCI compliance was actually attained, but still there was a problem with those workloads. And so when we start talking about what the wrong things are, essentially, there's an idea that somehow perfection can be achieved. But we know with the DevOps culture, and we know with trying to move faster and increase speed, these things really don't come with you very easily. And so you're starting to hear about things like compliance as code and trying to transfer this knowledge. But I guess the question really is, to what end?
Right, yeah. I think that's a great point. And we're trying to figure out what are the right things that people should protect, and not just this long, laundry list that we've been given and we've kind of passed down through the years. So let's talk about that. Like, what is the problem? We don't even know if we're chasing the right things. How are the current issues the right issues? We have to ask the question: is what we're testing driving us towards finding the right issues? Because if it's not, we maybe should consider not even doing that testing. And are we using the right tools? Are we able to discover this?
Yeah, one of the things that's interesting is if you're using tools, and you find stuff that is said to be critical, is it really critical? Are you finding things that are actually going to make your workload safer? This is really a big problem for the industry, and when we start looking at the research that's going to be discussed today, what we find is, how do we know? How can you be certain that the things that you're doing are actually going to make your software safer? And the truth is that right now, it's a laundry list of things that have happened over 30 years, as you well know, if you're a developer or what I consider to be a maker, because I think that actually requires operations and different kinds of things. But if you're a maker, you're essentially now trying to figure out, how do I get confident with this security stuff, even if it's on an iterative basis? What are the things that I have to do to ensure that a bad guy isn't going to do something bad with my workload? So let's flip over to the next slide.
Yeah, and it is a problem that we're facing. It's a what did we say earlier? We're saying it's an epistemological problem for developers and security to figure out what do we know.
Yeah, when you and I first started talking several years ago, I remember you're like, so what? I'm like, you just made my profession about so what? That's really difficult.
I don't know.
I've been doing this for 30 years, right?
I did not do that.
There was a bunch of so what back then. But now, what's interesting is over the years that we've worked together and we started to do this work, I brought a lot of the thought process about what is the adversary perspective. And, you're really talking about means, motive, and opportunities. And relatively, what's happened with the security industry is we focus a lot on opportunities. If we can block out the opportunity, then the bad guys are going to go away. But the truth is we're really not, as an industry, a tech industry, driving those bad guys away. We're actually just seeing them change how they think about opportunities. Oh, okay, well, if you're going to block this thing, then I'm just going to try it a little bit different way. Oh, you're looking for files that actually help you to determine that I'm doing something bad? Well, I'm going to do fileless breaks. And so there's a lot of interesting techniques that a bad guy can take advantage of. And so, what's the money that's going to go into the investment? How long are they willing to play the game with you? And then, ultimately, how bad are we writing our software? And so that's the opportunity. And so, the way I think about it is software shouldn't necessarily always be perfect, because if we're doing the right things for our customers, we might take risk.
Yeah,
and so I don't think there's riskless software in this world.
Right, and I think that is a key point that a lot of people have to take in, sit with that for a minute. If you think about this in the terms of those compliance standards and everything, all those things are a litany of instructions on how to eliminate the opportunity or make it smaller. Mm-hmm. But that is always in the name of perfection, and security kind of suffers with that as a problem. If we build the perfect system, it will be an unhackable system, but that is a fallacy.
And that should be a fallacy. And by the way, I think the other thing to think about on this slide is, who is your adversary when you're writing software? Is it your auditor? Is it your security team? Or is it really the bad guys? And the way I look at it is, a couple years ago, I had a developer come to me and say, all right, so what? In addition to all the so whats I had gotten before. Yeah. And I said, well, I think you're thinking about it wrong. As a developer, why wouldn't I be your best friend? Because I'm going to be able to mimic what a bad guy will do to your application far better than any of the tools can actually tell you to patch. I don't know if you've seen the CVEs lately, if you're even knowledgeable about it, what a common vulnerability is. But there's actually all these definitions, just like there's a ton of compliance requirements, there's a whole bunch about how to actually register a defect. And even before they even get into a developer backlog, there's actually common language between security folk to talk about whether or not something is a risk or not a risk. So there's all this backlog of information about how security can even talk to security. And so if you think it's bad between developer and security, I got to tell you, it even gets worse past that. But the way I look at it is the adversary in our organization is, the bad guy. And so the way that you have to get past this slide is really figuring out, who are you fighting?
I think that's an excellent point, and that's where we want to kind of take the direction here. So, okay, let's see.
You want to go to my funny security facts?
I love this because I think it helps people kind of think about security in a new way.
So I like writing comic strips, as you saw on my first slide of my introduction. I have been dieting because I had a kid a couple years ago, but I'm still trying to lose weight. I was must have been binging on nutritional facts and realized that somewhere in here, how do we actually understand security when we're making something? Like, are you building something that has too many calories? It's got actually bad stuff in it. And so when you start to think about this, one of the things that was really remarkable in the research that we've done is adversary interest by far was one of the leading indicators of whether or not your application was going to be successful and durable against a security problem long term. So no interest, no problem.
Yeah, and I think that's key. Well, okay, so tell us about your research. So I saw you do this, and then we started talking more about this.
Yeah, so I think I finally got value. I had a value proposition finally as a security professional after years of really awful dinners and discussions about how security needs to go away. And so I said, all right, I'm going to fight back. So how do we prove that I'm helping you work on the right things? And that comes from really trying to portray what is the bad guy traffic. Like if you're a developer, how often do you actually see this? So let me explain that for one moment. Bad guy traffic is your edge case. You're not going to even care. It's actually, out of the 99% of the stuff that you're going to worry about to create revenue, this is the 1%, or hopefully 1%, that you probably aren't really thinking about as a developer. Why would you chase the edge case? It's going to take a lot of your time to really get knowledgeable in this space. And ultimately, your biggest value is to produce a capability that your customers are going to want and love. And so they kind of are diametrically opposed. And when we started doing this research, we built Honey. So we have a website that basically is a Honey website. And it was supposed to be a WordPress site. It's not. It's built in Joomla. So already I'm throwing off the bad guys. And we're like, all right, come on and attack us. Let's put up all these signatures of all these WordPress vulnerabilities. And if you know a lot about security, you already know that WordPress is like a favorite among many. And so we kind of have tricked the bad guys to say, please tell us more about your WordPress vulnerabilities. And ultimately, we did it on AWS so we could kind of recycle fast. We can always restack if they did break into something that we didn't intend. They finally figured out it was a Joomla website. Well, then we could actually do something about it. We've also done some really interesting things to Joomla. In the scheme of things, I would actually say it's actually not that useful for somebody to try and even spend any time on it. But what we learned was by using scanners and by using detection as well, we got a wealth of information that was really useful for a developer.
Yeah, and so then we were talking as well, and so at Signal Sciences we have a lot of data on this thing, and we started noticing that, okay, like the OWASP top 10 is like the most recognized part of the problem, but it's not the real world problems that we're seeing across the board, and we're seeing more stuff like there's the iceberg here, and so we can't focus on always these. Like the industry kind of leads us to believe that we can focus on this stuff and like that's gonna solve our problem, but there's other pieces to it. And so here's some of those items listed here, but I think this is like a helpful way to think about it. And we notice across our attacks like that we'll see 5 to 10% like be OWASP type stuff, and then 20-30% be like stuff that people rigged up to instrument different flows, and then 70% of the attack traffic, 70% or so is looking at all the anomalous weird stuff that's happening that your application's emitting from that. And so
that's actually what brought us together is that one of the things that was really interesting is to figure out that the closer you instrument to your edge case, the more value you get out of the telemetry from a security perspective. And one of the things that caused me to really dive in pretty deep in this area and to explore adversaries at this level was when I started seeing a WAF breaker capability come in through SQL injection, where every header was different and every IP address was different, and there were calculations that were separate. And it looked like a SQL injection, so it totally registered on all of the OWASP top 10 stuff. But in essence, it was actually a totally different attack. They weren't attacking necessarily the application through SQL injection. They were attacking the security on the application to get somebody to turn it off, because they knew that that was actually what was protecting against SQL injection.
Okay.
So it's really interesting stuff.
Yeah. Okay.
So this is actually a builder slide. You're going to have to build all the way
I'll build
while
it.
you're building.
Do you want me to build in each one?
So yeah, let's just talk real quick. So one of the things that's interesting is I started doing this work to try and build a premise around how to deal with reconciling OWASP against real world and figuring out exactly how we were going to understand it. So if you look at this, you basically see that at the very bottom in really small print are the number of adversaries and IPs we were seeing. And generally, when you start to like shake out the OWASP top 10, you start to see injections pretty high on the list. And then perceived success. When your adversary perceives more success, they actually spend more effort on the application using that particular tactic. And so when we started looking at the OWASP top 10 and we were trying to figure out, like, what should we expect? We should expect this kind of behavior based on what we've heard through all of the work that's been done with the OWASP top 10. Well, when we really looked at the real world stuff, and you can go to the next part, we started seeing scanners, and they were clustering in this way. And so this is a lot of big data. I get about 2 petabytes of data per year to play with as a red teamer. That's kind of insane. And the reason it's kind of insane is because we've really shifted in a different way. You're going to see that later in this deck. But when we start looking at pooling, that actually showed us that, okay, we could pick out the scanners. The next part is researchers really kind of cared about a few things. By the way, the researchers actually didn't care as much as we thought about the OWASP top 10. They cared about 2 major things in there. They cared about your null byte and your cross-site scripting. But we saw this new thing emerge, which was subdomain takeover, which is really an old school attack that comes from like way, way back when, and I'm not going to even say when because I'd be really old in the scheme of things. And when you start to look at it, it was really interesting to see this work portraying itself, that we were actually picking up old attacks from a research perspective. Next part.
Yeah.
Paid noise. So you may not know this, but actually bad guys pay other bad guys to create cover and evasion attacks. And they do so in 3 different ways. Most importantly, when you see something that's actually just constantly spraying your website and there's really no rhyme or reason to it, it's pretty much called paid noise. And that helps to lay down tracks for what's next, which is basically your high-end adversaries that really want to break in, not the ones that are just going to go check to see if the door is locked, but the ones that are actually really creating a concerted effort. 1, they don't use too many IP addresses. They want to hide. 2, they spend a lot of time on things that they know are going to work. And their perceived success is actual success in many cases. So when you start to see what they're spending their time on, generally it's account takeovers, it's specific to your application. And so that's where our research combined, when we started looking at my work and his work together and some of the aggregation of data, we started realizing this is proving out kind of really interesting in a meaningful way, which was we're seeing a totally different shift based on every application to be profiled around the application. And so that means that your company is pretty much not under the radar. You're seeing bad guys that are interested in you for either lucky or good, and this is actually showing that difference. So to kind of go through these really quick, automated scanners showed up in this way. We saw a little bit of variation. It was continuously running. Yep. We saw day over day where these same behaviors, the same pattern actually replicated many times over. So we realized, we could actually build some AIML to make this go away. That was kind of cool. So we did that. The next one was researchers. What's interesting about researchers is there's researchers in the part of the world where you might live, where they spend their effort basically from like anywhere from 10 to 10 during the day. They like to wake up late. They tend to spend time actually working on your applications. And they have a specific pattern as well. They also work in paid bug bounties. And even if you're not on a bug bounty, you may see private disclosure come through. This was where we saw that pattern. Also, with paid noise that came through, if you look, it's actually a lot more systematic. It's usually continuous, it's automated, it's usually more uniform than all the other variances that we see when a human's actually involved, or when a scanner is actually triggered from some sort of automation. Next slide. Advanced adversaries are by far the weirdest. They have all these spiky anomalies. They actually want to hit you. They want to hit you fast. When you segment out that traffic, it becomes really interesting, because when a bad guy's really good, they actually will come in, they'll do it for a little bit of time, and then they go away, and they try to hide within the rollover of your logs. If you keep your logs for a really long time and you do replay, you might even find things that you missed. All right.
Okay, well, I think that kind of sets up the first half.
Yep.
But we're also hurting productivity, right?
Yep.
So when we look at this list, we see on the left, we see the OWASP top 10. But what does that mean? What does that mean
You've been
to us
ingrained to do the OWASP top 10, right?
That's right.
So
yeah,
those are
right.
the ones that you go hit, and you're like,
Right.
I built a bunch of scanners, and I'm going to try and make it productive for myself. And ultimately, what happens is we overwhelm our development partners by not focusing on the stuff that bad guys actually focus on. So with the real world top 10, when you're instrumenting your application, where you're looking for things like anomalies, like I didn't intend for this guy to actually travel to that directory or that web page. It's not usually done that way. Those things, when they're actually referenced in the right way, make it so that you have less guessing. And ultimately, this means that when you're fixing problems in your backlog, because I like to send stuff to the developer backlog, I want it to be prioritized within the rest of your work. If you got a P0, you should fix it right now. And if it could be done in 30 days, then do it in 30 days. But essentially, you got to have some way to have a conversation about what's real and what's perceived.
Well, and I think this is where we start changing the conversation to say, okay, let's be adversary driven, right? Let's not just focus on the big bullet list that we've been told, but what can we actually do here? So when you kind of conceptualize this, like, walk us through this pipeline here.
Yeah, this is the part where I said earlier, like, who is your adversary? Is it your security guy or gal? Is it your auditor? How are you thinking about it? If you're making software, the opportunity here is that the adversary is actually the bad guy, the guys that actually want to do something bad to your software. So now I like to say that I've made a lot more friends in our developer community because I've found a way to be valuable by having them send me a lot more telemetry. I can say, here's what this tactic is. You know, I care deeply about making these tactics more visible, making them easier to digest, and making it faster for developers to make them go away, and sooner within the pipeline. So if we can actually instrument something way sooner, and it's in your staging or your dev, testing these things out sooner, you know, my team spends a lot of time on mimicking traffic based on the stuff that we actually pull out of everyday workloads.
Well, and we see some of this as well, where if you want to add like observability, or that's kind of a hot buzzword right now, but like any sort of measurement and insight into like what's going on, you need to figure out a way to correlate both anomalous type of behavior or things that are going on the site alongside regular attacks, or alongside attacks that you're seeing, and just like regular application flows. So here's a quick example of that. Like, let's say you see a bunch of like HTTP 400s sort of spiking around your auth page, but then you start seeing ATO events, like, and those are like specific things like, you know, arise in like login failures or password resets or any of any of the ATO type primitives that you might instrument. And then later you start seeing like address changes inside of your system, you know, maybe they're you know, shipping new things to their house, or maybe they're trying out new credit cards, or could be anything, right?
I was always inspired by developers who cared about their HTTP access codes, because for me, they knew about their application, they knew performance and latency and all this cool stuff. But what I found was there was all this information. If you just stripped out the 200s, you could start to see anomalous behavior. And then when you added back 200s that were interesting from a bad guy perspective, you got to see like these two worlds combine, and all of a sudden you could actually determine, do I have an interesting defect in my application such that I'm actually luring bad guys to do something that's actually not intended?
And it's like, are we able to correlate across these separate types to help give us a real picture of what's going on.
Yeah.
I think traditionally we've just always focused on, is that cross-site scripting, yes or no, right? And that's a problem. Now, but the problem with that is, all that sounds great, but this level of instrumentation, it's going to vary, and it varies by what app you're running, by what vertical you're running, by what language. So just for like authentication, like we see authentication failure rates, wide, they're kind of very. There's a wide variation here across the verticals. So
and that's actually pretty consistent, because I used to be in the gaming industry,
Yeah.
and that 84% is totally dead on, which is really quite alarming.
Yeah, well, we ran this and was like, these numbers don't look right. And so I talked to somebody at an e-com site. They're like, yeah, most people don't know their password. They just reset it because when they want to go back to like buy something, that's what they do. And I'm like, oh, okay, cool. So,
and you also don't realize, but most bad guys are going after gaming sites for DRM purposes, that they break into accounts to actually get the DRM entitlements to be able to reuse. So it's kind of an interesting thing.
Yeah. Well, we also see just even like in login or ATO type stuff, developers or frameworks or just like the language itself, like will sometimes like have different ways of handling it. So you see just a login failure. Sometimes they return it 200 OK, sometimes a 400, sometimes a 401, sometimes a 402, and we saw this across a wide set of data that we pulled this from, and so. This is where you have to actually understand your application and know what you're dealing with here. So I know you have some other measurements you like to talk about.
So those are all the ones that James wanted from me. Was like, could you give me some more telemetry for an application? And I said, well, have you also considered some other ones, like adversary return rate? How often are you seeing an adversary return to your application? How do you know is based on their IP address, their headers, their pattern. You might even be able to determine their pattern by stuff that you do in your application. Rate of change, how often do they change their tactics? Are they trying different things on your application? They really want to break you. How much does it cost to fix? So most adversaries will actually go after your most important weakness based on how much it costs you to fix. And they know that because they know like something's really deeply ingrained in how you've built your application. It's actually long-term debt. So they're surfing for your long-term debt just as much as you're trying to get rid of it. And then mean time to identification is really an interesting thing as well.
Yeah. Okay, so what are some takeaways from
Yeah, it was
this whole
really
thing?
interesting. When we studied this data, bad guys are actually whitelisting through scanners. So like if you use White Hat or Qualys or Nessus or Nexpose or any of those commercial scanners, you're going to see headers that actually the bad guys are using because they know that most developers don't want to actually see that noise in their actual logs. So because you whitelisted as a developer, the bad guys know that, so they realize the first line of defense is just getting through those whitelists. The bad guys don't actually use commercial scanners. I hate to say this, but they don't even use some of the open source scanners. They write their own things because that they know that those are harder to detect. There's not a lot of signatures for them, and they can kind of ride through all the security stuff that requires those capabilities. They have a bunch of go-to TTPs, techniques, tactics, procedures. Quite often you're seeing cryptocurrency, because it's actually such a big thing now, become the big deal. So if you're leaving your workloads open or there's some way to make money off of your stuff through cryptocurrency, that's the go-to.
Yep.
And they're not afraid of using AIML. We might all be learning it, but they've been doing it for a long time. In fact, they were investing in it for a long time. And they hide in a lot of noise. So I think one of the things that's really helpful is when we started doing this work, we came back to a premise, which was if I could give a developer 5 things to actually keep track of, could they make their application more meaningful and useful against a bad guy? And these 5 things, if you have to remember 5 things you need to do well, you got to zone and contain your application decently. You've got to be able to have asset management, logging, authentication, and encryption. And I didn't put access control because I know that the devil of access control is really in authorization and role management, and we all know you all love that much. But really, ultimately, this is the thing that if you get 80% of the things that you want done here, you'll actually cause your workload to be safer.
Well, and I like too how we can think about it. If you go forward thinking I got to like make something perfect, that's like not the right way, right? We need to think about this in sort of a crawl, walk, run scenario.
Agile and DevOps say that we're all going to learn over time, and so we're going to get better and develop skills by crawl, walk, and run. So, these slides will be available later, but I think it's really important to start instrumenting your technology.
Well,
Space.
and we need to make our last thing like, what can you help us with? So our big request to everybody here is that we are writing a book along with Ernest Muller and John Willis, and we're looking for stories of DevSecOps transformation, journeys, successes, failures. I don't know.
And case
rhetoric.
studies,
We're open for anything.
Debate.
Yes,
you want to
right.
drink with us later, come debate and help us understand where we might have more perspective on the matter.
So, and I know we're kind of out on time, but really thank everybody today for your time.
Thank you for your time.